How to calculate a logistic sigmoid function in Python? This is a logistic sigmoid function. I know x. How can I calculate fx in Python now? Let's say x equals 0.458. fx equals?
This should do it. And now you can test it by calling update. Note that the above was mainly intended as a straight one-to-one translation of the given expression into Python code. It is not tested or known to be a numerically sound implementation. If you know you need a very robust implementation, I'm sure there are others where people have actually given this problem some thought.
It is also available in SciPy, this URL, which is only a costly wrapper because it allows you to scale and translate the logistic function of another SciPy function. If you are concerned about performances, continue reading, otherwise just use xspit. Some benchmarking. As expected, logistic.cdf is much slower than xspit. xspit is still slower than the Python sigmoid function when called with a single value because it is a universal function written in C. This URL, and thus has a call overhead. This overhead is bigger than the computation speedup of xspit given by its compiled nature when called with a single value. But it becomes negligible when it comes to big arrays. You'll notice the tiny change from math.x to np.x. The first one does not support arrays, but is much faster if you have only one value to compute. But when you really need performance, a common practice is to have a pre-computed table of the sigmoid function that hold in RAM, and trade some precision and memory for some speed, for example, this URL. Also, note that xspit implementation is numerically stable since version 0.14.0, this URL.
Here's how you would implement the logistic sigmoid in a numerically stable way, as described here. Or perhaps this is more accurate. Internally, it implements the same condition as above, but then uses log1p. In general, the multinomial logistic sigmoid is. However, log@xp.reduce could be more accurate.
Another way by transforming the tanh function.
If you want to see more, please consider subscribing.